Hello, welcome to part 2 of Unit 1.5. So now we're going to talk about an angle bisector. So an angle bisector is a ray that divides an angle into two equal parts. So in this case, the ray would be BM. Remember, rays have one endpoint, and on the other side, they continue infinitely. So this is our angle bisector. And it divides an angle into two equal parts. So our angle in this case would be ABC, so this entire angle, and it would divide it into two equal parts, which is ABM and then angle MBC. So it says here, angle ABM and angle MBC are adjacent. Now, adjacent is just a fancy word to say next to each other. So they are adjacent because they share a vertex. In this case, the vertex is B. And I just want to remind you that a vertex is where two rays meet or where two line segments meet. In this case, it's where two rays meet. So this is one ray, this is another ray, and they meet here, so that is the vertex. And they also share, and the two angles share a side, so this would be the side. That means this angle and this angle, they are adjacent to each other. So let's get into our second postulate, the angle addition postulate. Remember, our first postulate was the segment addition. So now this is actually very similar, but it's now talking about angles. So it says if point D is inside angle ABC, then angle ABC would equal to angle ABD, this smaller angle, plus angle DBC, this other smaller angle. And if we do the math, then we would know it is 105 degrees. Yes. So that means angle ABC is 105 degrees. Now, this seems straightforward since we are already given the values of the angles, but it's important to keep in mind later you might be given algebraic expressions for these angles and you would solve. Now, this says that this angle is 45 degrees. What does that number really mean? What does 45 really mean? It's actually just the measure of the angle, so it's the difference between the direction of the two rays. Okay, so now let's get into, special pairs of angles. So remember we talked about zero angle, straight angle. Those are defining a single angle, but now we're going to talk about a relationship between two angles. So first one, supplementary angles. These are two angles that add up to 180 degrees. So this angle is 120, this one is 60, and they add up to 180. So we would say these angles are supplementary. Linear pair. These are angles that add to 180 and are adjacent. So 120 plus 60 is 180, and they are next to each other or adjacent. Next is complementary. These are angles that add to 90 degrees. So this angle, 25 plus 65, makes 90 degrees. Complementary and adjacent, these are angles that add to 90 and are adjacent. So you see these are next to each other. So you see this trend of supplementary and also supplementary and adjacent, complementary and adjacent. So these are really to describe a relationship between two angles. Lastly, let's talk about congruency. This is when two segments or angles have the same measure, so they could have the same shape or the same size. And how do we represent congruency? Well, we can actually use what we call hash marks for segments or arcs. So congruent segments would have the same hash marks. For example, segment AC and segment AB both have a value of 3, let's say 3 centimeters. So they are congruent because they have the same measure, which is 3 centimeters. So we can label them with 1 hash mark, or 2, or 3, it wouldn't matter. As long as they have the same hash marks, that would indicate they are congruent. Now, segment BC is 5 centimeters, so it is not the same measure as these two segments. So this segment is not congruent to this segment or this segment. So we would give it a different value of hash marks. So we can give it 2 hash marks, or we could give it 1, and we could give these 2, or yeah, it doesn't matter. As long as the congruent segments have the same value of hash marks. Now, how do we indicate congruency for angles? What we would use are arcs, and they look like this. So this angle, ABC, is 45 degrees, and angle ACB is 45 degrees. They have the same measure, 45 degrees, so we would give them the same value of arcs. And this other angle, 90 degrees, it does not have the same measure, so we could give it 2 arcs or something. So one thing to keep in mind is that congruency does not necessarily mean equal, and you'll see why later, but just be careful. And so congruent and equal are not synonymous. Now, how do we represent congruency in writing? Like we said before, we said angle ABC and ACB are congruent. So how would we write that? Well, we write out the angle, and what we do is write an equal sign and squiggle line on top. This basically says angle ABC is congruent to angle ACB. How do we do that for line segments? Same thing. And that's basically it for congruency for now.